So welcome to the August 2024 Regents review. This is only with light of units 1, 2, and 3. This is not including anything in 4, 5, and 6. Just throwing that out there. Okay. So the first question, we circled 20 questions that we can do at this point, and they are worth 2 points each. So that's 40 points. And 40 points is an equivalent of 75% on the Regents right now. That's just with the multiple choice. That's not with short response, but short response will be in another video coming up. All right, so throwing that out there. So question number 1. Grocery store owner wonders how many customers. You can read the question. So an employee stands at the entrance for 2 hours and counts the number of people bringing in reusable bags. This type of study is best classified as. So a census is a population count. Usually this is national or global. So since we are not counting people in the globe, how many people are in the world, so on and so forth, that is not it. An experiment we know, and that typically deals with two groups. One is a controlled group and one is an experimental group. So it is not that we are not dividing into two different places or two different things. It's not a survey. You all have taken a survey before, right? It's usually like a form with questions of people's opinions on things and so on and so forth. So it is not that. It is an observational study. In an observational study, what you're doing is you are looking at participants. You're just observing. It's exactly what it sounds like. And you might be like figuring out some information or counting people bringing reusable bags in. That is an observational study. Okay. Question number 2. It's asking you which ones are positive on which interval. So we're taking our calculator. We're going to go ahead and plug it into the calculator. So you go into y equals, plug in 2 to the x minus 4. And when we hit graph, you're going to get something that looks like this. So right now it's negative, and then it goes boom at 2 comma 0. I can verify that, right, by going to the table. At 2 comma 0, it is 0, which 0 is neither positive nor negative. But then after that, you see how over here in the y's, these are all negative until it gets to 0. And then all of these after that are positive. So where is it positive? It's positive from 2 all the way through to infinity. The reason why it's not like this with brackets is because the 2 is not being included, right? So at 2, the one across from the 0, and again 0 is neither positive nor negative, so that's why it's not brackets, it's with the parentheses, which means not included. All right, this one right here, you can do this with the store button. Store in a number for x. I usually use 2.1. You cannot use 0, 1, or 2. Cannot use those numbers. You could do this with y1, y2. So you can plug this into y1, plug each of these into y2, and see which one is the same. Then I'm going to show you how to do that using the store button. So let's go 2.1. We're going to hit store. We're going to hit X. The store is above the on button. And now we're going to plug in the function. So 300 parentheses. So just so you know that these brackets are also parentheses, just throwing that out there. So 1 plus, and then alpha y equals option number 1 to get that decimal. So 0.027 over 12. And again, you should be doing this along with me to the 12. And instead of t, we're going to use x because that's the variable that we defined. And we get 317.481. So 317.481. So that's what we want to see which one matches, is the same thing as. So let's go for the first one. So 300, and again, those brackets mean parentheses. So it's double parentheses, 1.00225. Close those parentheses to the 12. And then we're going to go to the right, close those parentheses to the, and again, we used x, and boom, these two are the same. So the option is number 1. Everything else, if you can check, does not work. For this one as well, you could use the store button. You could use y1, y2. How do you do that, right? Whatever's on this side, y1, whatever's on this side, y2, and see if they match. You can use the store button. So plug this in, hit enter, get an answer. If this one is the same thing, then that is correct. For this one specifically, I want to show you how to do this the longer way. So the longer way is multiplying, right? We want to see if it equals this. So x times x to the third is x to the fourth. X times negative x squared is negative x to the third. X times x is positive x squared. When I go like this is going to give me positive x to the third. This is negative x squared, and this is positive x. So this is just cancel, cancel, and you're left with x to the fourth plus x, which is what we have. So it's choice one. It's not always going to be choice one, but in this case it is. We know it cannot be 2 and 3 because you see how these middle terms canceled out? One's positive, one's negative, they canceled. When all the signs are positive, how are they going to cancel out, right? They're not. So all you had to do is really test 1 and 4 if you knew that. Question number 5. Again, you could go to y1, y2, see where they intersect. That's one way to do it. You can store each of these numbers in for the x. As soon as, so just watch real quick. As soon as you put in negative 3 plus 3 is 0, right? You can never have a 0 on the bottom, so it cannot be negative 3. It also cannot be 4. X cannot equal 4, and x cannot equal negative 3. Because if you put 4 in here, 4 minus 4 is 0, and you cannot have that. So those two cannot be it. I do want to show you how to do this. Those are called extraneous solutions. I do want to show you how to do this the longer way because we did do this. And if you want to use the calculator for this, fine, no big deal. But like I said, I want to show you the longer way because in case this is on a short response question, you should know how to do this. So how I showed it to you is you want to get these denominators to be the same. We're going to go ahead and factor this on the right side. Has to add to give you negative 1 and multiply to give you negative 12. Cool. What are those numbers? Negative 4 and positive 3. It's no coincidence that this says exactly the same thing. Okay. So if we have x plus 3, but we don't have x minus 4, the x minus 4 is missing. So we're going to multiply the top and the bottom by x minus 4. Okay. On the second one, the x minus 4 is there, but what's missing? The x plus 3. So we're going to multiply top and bottom by x plus 3. Okay. Now that the denominators are all the same, you can get rid of them, right? Remember, we did this lesson around Halloween. So now all you have to do is solve this. So x times x gives us x to the second. X times negative 4 gives us negative 4x. Okay. Then I have plus 2 times x gives us 2x. And 2 times 3 gives us 6 is equal to. And on the right side, all I have is 2x plus 27. All right, cool. So let's combine some like terms here. X squared minus 2x plus 6 is equal to 2x plus 27. We want to set one side equal to 0. It's easier to keep this x squared positive. So minus 2x minus 27 minus 2x minus 27 cancels. So x squared minus 4x minus 27 is equal to 0. Good. This is what we want. So we're looking for two numbers that multiply to give us negative 27 and that add to give us negative 4. What are they? Wait, not 27. 21. 21. 6 minus 27 is negative 21. Okay. So what are they? 7 and 3. And the 7 gets negative because this 4 is negative and this 3 gets a positive sign. Negative 7 times 3 is negative 21. Negative 7 plus 3 is negative 4. So our two double bubbles are going to be x minus 7 and x plus 3. We're going to set them both equal to 0. So here x minus 7 equals 0. Add 7 to both sides and you get x is equal to 7. And on this side, x plus 3 equals 0. Subtract 3 from both sides and you get x is equal to negative 3. Again, you cannot have negative 3, right? That's extraneous. This does not work. So the only answer is x equals 7. Okay. And again, you could have used this by the store or y1, y2. Okay. Question number 6. I want to show you how to do this in the calculator using a different method. So keywords here are best models. So you should definitely underline or highlight that. That is a trick. So it's not going to exactly fit. But what you do here is you go to the stat button. You hit option number 1, which is edit, and you're going to put these numbers in. All right. So once these numbers are in, the next thing we're going to do is, if you just were to go to y equals here and clear what's here and you just hit graph, you don't see anything. And the reason why is because you see above the y equals it says stat plot. We need to turn that on. So you hit second y equals, option number 1. We're going to turn this on. And now when you hit graph, you're going to be able to see the first one. So the first one, that the only one that you can see is 0, comma 0.05. You can't see these because these numbers are bigger than what we have. We have to change our window. So let's do that. Let's go ahead to window. And our x's, do you see how it's ranging from 0 to 111? So that's what we have to change our x's to be. So let's do that. So let's make it 0. And instead of 111, let's go to 120. And let's just say we want to go up by 5s. All right. For the y's, small numbers, right? It goes from 5 cents to $2.75. So we can leave it as 0. And let's go to, instead of 2.75, let's go to about 3. And cool, we can go up by 1. And now when you hit graph, look, you see those, right? Awesome. So now all you have to do is take each of the 4 choices that are there and plug them in. So we have y equals 0.0375. Oh, it deleted it for me. Parentheses 1.0392. Close those parentheses to the x power. And then I'm going to hit graph. And you're going to see that it goes through a lot of those points. It doesn't go through every single one. And that's why I asked you to highlight best models, right? It doesn't have to be exact. It just has to be pretty close. And you're going to see that choice 1 is the one that is the closest. I'm going to show you why, right? If I go to y equals right here and I type in the next one, right? 1.0392 parentheses, only one parentheses, 0.0375, close parentheses, to the x. Watch what happens with the second graph. You see how it's nowhere close? So that's not right. The 3 and the 4 are not going to also work. This is going to be a straight line. So the one that best models, again, keywords, is going to be choice 1. Choice 7. Again, you could use this using the store button. You can do y1, y2. So this gets plugged under y1. Each of the choices gets plugged in under y2, and you see which one matches. Okay. You could also, for this one, use remainder theorem, and I'm going to show you that one. Or you could long divide. I don't know why you would in this case, but you could. Okay. So remainder theorem is the easiest one to use for this one. And remainder theorem says you take the denominator, whatever you're dividing by, and set it equal to 0. So minus 2, and you get x is equal to negative 2. Cool. Now you go to your calculator, your regular calculator, and you're going to go ahead and store in negative 2. So negative 2, store it in for x. Okay, and then you're going to plug in just the top. So 6x to the 4th power, go to the right, plus 4x to the 3rd power. Again, go to the right, plus x, plus 200. And whatever answer you get after this, when you hit enter, is your remainder. So the remainder is 262. So the remainder is 262. The first one says you have a remainder of 166. The second one says you have a remainder of 266. The third one says 330. We don't want that. We want 262, and that is this one right here. So the answer choice is choice 4. And again, this is the easiest way to do this problem, but you do need to know remainder theorem. Okay. Again, you could use store, you could use y1, y2. You have 3 hours for the exam. You could do that as well. For this one, you could also use store. You could also use y1, y2. Here's y1, here's y2. See where they intersect and then match. Okay, so let me show you how to do this the longer way. Well, the way that we did do this in class, it's been a minute, so that's why I want to go through it this way. That way you learn it. Okay, so the goal is we're going to get this weird thing, I call this the weird thing, by itself. And the way that we do that is dividing both sides by 6. So let's do that first. So you have 2 to the x plus 4 power is equal to 6. Cool. So now what we want to do is we want to find x, right? But the x is in the exponent. The opposite of an exponent is a log. So here's our base. Here's our exponent. Here's our answer. So we want to go from b, e, A, and we want to go to B. Base, answer, exponent. Okay, so let's do that. So our base is 2, so I'm going to put my base here. The answer goes after it, so I'm going to put my 6 here, and it's going to equal my exponent. My exponent is x plus 4. So I'm just repositioning it. Okay, my base goes here, the answer goes here, and the exponent goes here. Okay, cool. Once you have that, how do you get the x by itself? Subtract 4. Subtract 4. So this cancels out. So you're left with log base 2 of 6 minus 4 equals x. This is not the same thing as 6 minus 4. Okay, so now what we're doing is we're looking to see something that matches. It is definitely not this one. All right, so what you're looking for is, we don't have any logs, but we could use ln and log. The concept is the same. You see how log 6 is on the top, so ln of 6 is going to be on the top, and then the log 2 is on the bottom, so ln of 2 is going to be on the bottom, and this is going to be minus 4 equals x. Let's just say you didn't know that. Okay, we haven't done this in a minute. I might not have shown it to you this way, but you could have taken, let me show you how to plug in the log. So you could have taken what we had over here, which is log base 2. No, my bad, over here, which is log base 2 of 6 minus 4. So log base 2, you see, for log, if you hit this log, the one that's above the ln, you don't get to put the base. So how do you get the base there? You hit math, go down to the bottom, log base, and now you can put the 2, you can go to the 6, go to the right, minus 4, and we have this answer right here, and then you just have to match. And if you plug in this one right here, which I'll show you how to do that, alpha y equals option number 1, ln is above the store button, our prized possession, and then we do ln of 2, close those parentheses, and we do minus 4, and you'll see that that gives you the same answer. So it is choice 4. Okay. Number 9, asymptote. Remember, an asymptote is a line that the graph never crosses. So what we want to do here is we want to plug this into our y equals. So let's clear what's there. I'm just going to do second plus 712 to clear my calculator. And once I do that, I'm going to type in my function here. So 5. This log doesn't have a log base, so I can just hit log, and then I'm going to do x plus 4. And now I'm going to hit graph. And what that does is it shows me something like this. Okay, so here's my graph, and you'll see that over here, it crosses at 3, and it goes something like this, something like that. And you'll see over here at -4, this line right here, this vertical line, at -4, the graph never crosses. What happens to the graph over here? It gets really, really close. The calculator doesn't show you this, but it gets very, very close to that -4, but it never crosses it. And if you're like, I don't believe you, miss, you can hit second graph, and you can go to all the way up. You see this right here? See how it says error? But let's just say I hit second window, which is the table set, and instead of going by 1, let's just say I went by 0.001. I just want to show you what happens here. And over here, I want to go to -3. Okay, so I'm going to go back to my table, and you'll see what starts happening over here, right? You see how at -3, right, there's still numbers, right? It gets, again, it's getting very, very close. Those numbers are getting very, very small, right? Which is why it's getting close to this -4. But at no point is it going to go like this. Okay, it's never going to cross it. And you could see that by, if you keep going up right here, these numbers get very, very small. But the second I go to second window and I go to -4, you should see an error. Yeah, across from -4, do you see that? There's an error there. So this line that we're looking for is at -4. Now my question is it, and the only one that says -4 really is this one. But it's x equals -4. It is not y equals -4. And I can prove that to you because if I went over here to y equals and I put in -4, you'll see that it is not a vertical line. It's a horizontal line. Let me just show you that. See -4? So we don't want a horizontal line, we want a vertical line, right? Our asymptote is vertical. So x equals -4 is our answer. Number 10 is not part of units 1 through 3. Number 11, again, you could do y1, y2, see where they meet. That is probably, in this case, the easiest. You could use store each of these values in. But I want to show you this, the way that we did this in Unit 1, Lesson 2. So this says 2x plus 6. Okay. So how we do this is we want to get the weird thing by itself. Right now, the weird thing is the radical part. How do you get rid of a radical? By squaring. So we're going to square both sides. Okay. What does that allow us to do? The square root and the square, they cancel each other out. So all you're left with is 2x plus 6 on the right. And on the left, you have x minus 1 squared, which is x minus 1 times x minus 1. Foil this out, you're going to get x squared minus 2x plus 1. You should actually do it, okay? Don't jump like I did. You're going to get one side equal to 0, so minus 2x minus 6. That cancels out, so now you have x squared minus 4x minus 5 equals 0. Cool. So we're looking for two numbers that multiply to give you -5 and add to give you -4. What are they? 5 and 1 should work. -5, +1. So we have x minus 5 and x plus 1 equals 0. Split them up and you get x minus 5 equals 0. Switch the sign, x is equal to 5. And you get x plus 1 equals 0. Switch the sign, you get -1. So these are the two that we have to check. So how do we check it? We take our 5 and we plug it back in wherever we see an x. So 5 minus 1, does that equal the square root of 2 times 5 plus 6? And 5 minus 1 is 4. This side is going to give you 16. The square root of 16 is 4. That works. So 5 works. That means 3 and 4 are not our answer. Now let's check our -1. -1 minus 1 is equal to the square root of 2 times -1 plus 6. And we get -2 is equal to the square root of 4. And that is not true. Okay. The square root of 4 is not -2. It is +2 when we have multiple choice. In a short response question, the square root of 4 is equal to positive -2, but in multiple choice, it's always just a positive value. So 5 works, -1 does not work. That means that the answer choice is 2. Okay, because number 1 says 5 and -1 both work. And if you were to plug it into y1, y2, you'll see very clearly that there's only one solution. All right, question number 12. You can store this, plug this whole thing into the calculator, get an answer, and see which one matches. But I want to show you how to do this the quote-unquote longer way. So we have 1 over x to the -2nd, and this whole thing is getting raised to the -3/4 power, which means that you can split it up, right? So this -3/4 goes for the top and for the bottom. So 1 to the -3/4 and x to the -2nd, all raised to the -3/4. Okay, how do we do this? 1 raised to any power, if you put that into the calculator, is just going to give you 1. So far right now, we know we're going to have a 1 over. So it's not this and it's not this. You see what we just did? We eliminated half of it. When you have a power to a power, you're going to take these babies and you're going to multiply it. And this is equal to x to the 3/2 power. You can use your calculator to do that if you didn't know. So what does that mean? That means that you can rewrite this as, right, this bottom number is our root, this top number is our exponent. So you can rewrite it as a root of a 2, the x goes here, and there's a 3 there. Automatically, I know it is not 4 because you see how they switched it? They said that the root is 3. Our root is not 3, our root is 2, right? The bottom number is 2. So it's not choice 4, it has to be choice 2. But let me just show you, in case this is not multiple choice, how you do this properly, okay? So we have 1 over the square root of x to the 3rd, which is 3x's. So there's an imaginary 2 right here, okay? So what does that mean? That means that we're looking for groups of 2, right? How many, do we see this group of 2 right here? There's one group of 2 that comes out. And then there's still this little x still inside the radical. So the radical x stays, the 1 goes on the top. That looks exactly like choice 2, right? 1 over, let me make that smaller, x rad x, and that is choice 2. And again, you could have used store for this question, or y1, y2. Okay. Question 13, we did not talk about at all, so I'm going to skip that. Question number 14, we talked about this quite a lot, actually. So, a fourth degree polynomial, okay? Um, so that means that it's going to look something like this. Y equals x to the fourth. Degree just means the highest exponent. So if you were to graph it, you're going to see that that looks something like this. Y equals negative x to the fourth is going to look literally the opposite. It's going to look something like this, okay? But it says with a positive leading coefficient, that means that we do not have this scenario. It is not going to be negative. It's going to be positive. So it's going to look up. So automatically 3 and 4 are wrong. Why? Because these are facing down. Do you see that? All right. So now let's keep reading. It says with two real zeros. Zeros are where it crosses the x-axis. Okay. So let's check it. So here's 1, here's 2. That means that that's the answer. Okay. Over here, how many zeros do we have? We have 1, 2, 3, 4. According to our description, we don't want 4, we just want 2. So the answer choice is 1. It says and 2 imaginary zeros, which means that it does not cross the x-axis at all. Cool. Question number 15. You can do this with the store button. Store number, put this in. Before you put this in though, your mode, if you're going to put this using the calculator, your mode has to be in, I'm going to go down. Do you see how it says a plus bi? Because you have an imaginary or an I, you have to put your mode like that if you're going to use the store button. Otherwise, it's going to give you an error. So put your mode. I'm going to make sure we write a note. Put your mode in A plus BI form if you're using imaginary numbers at all. But you could plug this into the calculator, get an answer, and then see which one matches. Because we did do this, I'm going to show you this the longer way. Okay, so let's clear our parentheses by distributing. 5i times 2x gives you 10xi. 5i times 3i gives you 15i squared minus x, and then this is rad negative 9. Okay, so rad negative 9, let's talk about that real quick. Rad 9 is just 3. Rad negative 9 is 3i. So I can write this as 3i. Let me just don't forget that x here. So there's a x here, and then this is times 3i, because our square root of negative 9 gives you 3i. I squared is the same thing as negative 1. How do I know that, right? If I take my calculator and I go here and I go second dot, which gives me the I, and we square it, we get negative 1. So I'm going to take my I squared and put a negative 1 there. Plus sign comes down, 10xi comes down. Okay, 15 times negative 1 is negative 15. This is 10xi, and this becomes negative 3xi. So the negative 15 comes down. 10xi and negative 3xi combine to give you positive 7xi, which means that choice 4 is the one that's correct. All right. Question 16. For this one, it's asking you for the focus. So I showed you how to do this with a graph, but we have this weird looking equation here. The equation that we went through in class was y equals 1 over 4p parentheses x minus h squared plus k. And our h and our k are our coordinates of our vertex. The p is the distance from the focus to the directrix. No, from the vertex to the directrix and from the vertex to the focus. Sorry, I said that too quick. Okay, so we have to get what we have here in the form that we have. Okay, so let's get that y by itself. I can notice that over here, to get the y by itself, I can divide everything by 8. So I have, this cancels out, I have y plus 2 is equal to x plus 5 squared over 8. Cool. The y is almost by itself, right? Minus 2. What am I writing? Minus 2, minus 2. Cool. So I get y is equal to x over 5 squared. This is, I have to make it look like 1 over something. So 1 over 8 times x plus 5 squared minus 2. All right. So this is enough right now for me to get my h and my k. This one, the first one flips. I flip it, and then I keep the second one. Keep. So the opposite of positive 5 is negative 5 because I flipped it. And I'm going to keep the second. So it's negative 5, negative 2 is the coordinates of my vertex. This right here, you see how it's 1 over 4p? So I have 4p is equal to 8. Well, how do I get p? Divide both sides by 4, so I get my p is 2. Okay. At this point, we should stop and find a sheet of graph paper. Okay, and on the graph paper, we're going to draw what we have. So our vertex is negative 5, negative 2. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 2. I'm going to put a point. That's my vertex. Okay. Remember, the vertex is when I have my parabola, it's going to be the point at the bottom or at the top, depending on where it's going. My P, though, you see how it's positive? That means that it's not going to be facing down. It's going to be facing up. My parabola is going to be facing up. So it's going to look something like these. It's going to move up. Okay. So now let's figure out where my focus is going to be, because that's what it's asking you for. My focus is 2 points away from where my vertex is. So here's my vertex. My focus is going to be 2 points away from that, right? So it's going to be, here's going to be my focus. Cool. That means my directrix is going to be 2 points below my vertex. So my directrix, or my line, is going to be over here. See, this is 2. So our P is equal to 2 here, and our P is equal to 2 here. So the answer to our question is, what is the focus? The focus is at negative 5 comma 0. And if I go scroll back up to the top, now my question is, let's see if that answer is there. It would be really bad if it's not. But negative 5, 0 is our answer. And boom, there it is, right? Negative 5, 0 is going to be our answer for that. And I'm going to just write C graph paper. Okay. This question is easiest to do using y1, y2. Plug this into y1, plug this into y2, and see where they intersect. All right, so I plugged it in, and now I'm going to hit graph. You need to make sure you can see the point of intersection, otherwise you have to change your window. That's the first one. The second one does a little loopy, and you can see that there's one intersection. So second calc or second trace, option number 5. And I'm going to move closer to where it is. There's only one in this case, so get as close as you can, and then hit enter, enter, enter. 3.72, 3.7. Okay. If you wanted to sketch it, you could. And then, right there. All right. For this question, you would need to have the volume formula using length, width, and height. So volume equals length times width times height. Unfortunately, this is not given to you on your formula booklet. Technically, you could do this on the calculator once you get this next thing over here. So anyway, length times width times height. So our length is given. It's 18 minus 2x. Our width is the same thing, 18 minus 2x, and they tell us that the height is x. So a couple of things you could do is you could FOIL out the first and then multiply it by x, or you could take the x, distribute it by one of them, and then multiply that by the other one. I'm going to do it the first way that I said. So 18 times 18 looks like it's going to be 324. You can use your calculator to show you that. 18 times negative 2x is negative 36x. We're going to have another negative 36x, and then this is going to be plus 4x squared. And this whole thing gets multiplied by x. Don't forget that. So this becomes 324 minus 72x plus 4x squared. And this whole thing gets multiplied by x. So I'm going to rewrite it in the order that we have. 4x to the third minus 72x squared plus 324x. And that is answer choice 2. Hopefully that makes sense. For this question here, you could definitely use the store button. But the most the most common question I got is, Miss, how do we put this little 6 here? Like I know how to do a square, but I'm going to show you this using the store button just to show you how to do that. So let's clear out of this. So let me go back. Let me see what my x value is. Okay. I can leave it like that, or I could just store my usual 2.1. So 2.1 goes stored into x, and then I type in what I have. So it's 8 to the alpha y equals option number 1, x over 2. I go to the right, times 8 to the, and then same thing, alpha y equals option number 1, x over 3. All right, now I'm going to hit enter. So my magic number that I want is 38.05. All right, something. So now I'm going to show you how to get that 6 as a root. So you're going to put the 6 first, then you're going to hit math, and you see option number 5. Number 5 has the xth root. Number 4 is the third root. I don't want that. So option number 5, and then now I see that 6 is in the root, which is what I want, and I go 8 to the, and I'm going to write 5x. And boom, those are the same answers. So that's our answer. These do not work. And you could check that. Go away, please. Okay. Question number 20 is not one of the ones that we've done in units 1, 2, and 3. It's not bad. Question 21, the only way you could do this is by knowing polysymbol 2. And you can get that using the apps button. So I'm just going to show you where that is. So the apps is the only purple key on the keyboard. So you're going to hit apps. And then at this point, what you're going to do is you're going to find polysymbol 2. On your calculator, it should be option number 9. On mine, it's 2. On some calculators, it's 8. But wherever it is, you're going to find it. And then it's going to instruct you to prompt to do any key. Over here, you see how we have 3 equations? It's in the right order, x, y, and z. All of them have to be in the same order. You can't have like an x, y, z, and then on the next one, a y, x, and z. So we're going to hit option number 2 because we're not looking for roots. We're looking for the solutions. All right. So how many equations do we have? Again, we have 3. So hit 3. Go ahead, enter. Unknowns are 3. I don't care if it's decimals or fractions. So I'm going to hit graph. And now you're going to put the numbers that are in front of the variables. So for 3x, you're just going to put in 3. So common mistakes are that, like you see how here with the -5, people do not put -5 there. They just put 5. And another common mistake is when you're putting in the last number, the 3, you have to make sure you hit enter after it. And then when you hit graph, it will give you your x, y, and z in order. So we're just looking for y here. So y is the second number, which is 3. So 3 is our answer. If you had all the solutions like x, y, and z, you could use the store button. We didn't do 22. All right, we're almost done. For question 23, the easiest way to do this is by using the store button. I just want to tell you one thing really quick. So they want you to pick number 1 as your answer. It is not correct, and I'm going to show you that in a bit, okay? But the reason I want to do this question is because you see how here the y, if you're going to put, you cannot put this into y1, y2 because you would have to get the y by itself for all of them, and that would be a lot of work, and you probably will get it wrong if you do it like that. So the easiest way to do this is with store. So let me show you how to do that, okay? I'm going to go to my faithful 2.1, store it in for x, hit enter. You can store any other number in for y as well. I usually use 4.7. So 4.7 store. How do you get y? Do you see how above 1 in green there's a y? So to get that, you hit alpha 1 and then hit enter. So now x is 2.1 and y is 4.7. Cool. So x to the 8th, go to the right, minus y, so alpha 1 to the eighth as well. So our target number is negative 237,734. So negative 237,734. That's what we want. If you plug in the first one, right? X minus alpha 1 for y, close parentheses, to the eighth. Look, you don't get that. It is not that. The correct answer here, when you get to it and you plug it in, is going to be choice 3. 3 is the one that matches exactly. It's a little bit to plug in, but you have 3 hours. 1, 2, and 4 do not work. All right, the last question. So for this one, first year salary of 90,000. This is our A1. A1 is $90,000. Cool. And a 2%. As soon as you see a percent, you know it's going to be a geometric type of question. Okay. So there are two types of geometric, and this is in your formula booklet. So the first one is a geometric series, and the second one is a geometric sequence. What's the difference? A geometric sequence is when you have like 2, 4, 8, 16. You see this? It's getting multiplied by 2. That's a geometric sequence. A geometric series is when you take these numbers and you add them up, right? That's the difference. That's a geometric series. A sequence is just like when you're looking, if you're like, hey, let me find the 10th term, then you would use the geometric sequence formula. The geometric sequence formula is this, r to the n minus 1. The geometric series formula is one that looks like this. It's a1 minus a1 r to the n all over 1 minus r. Okay. So again, series is when you add up all the numbers, the total, and sequence is when you're looking for like the 10th term or the 100th term. So let's see what this is asking us for. Through the first 10 years in total, do you see this? So we know automatically right now we're going to be using this formula. So Sn is equal to A1 minus A1R. I usually have you put it in parentheses to the n power all over 1 minus R. Okay. So for our R, it is increasing at a rate of 2%. So here is our rate is 2%. That is the same thing as 0.02 as a decimal. If it's growing, you're going to take that number and add 1 to it. So this is 1.02 or 102%, right? It's growing at a rate of 102%. The reason why is if it was just growing at 2% and you didn't add that 100%, you'll see that those numbers get smaller. We don't want that. We want our money to grow. So our A1 is 90,000. So I'm going to write that down. Minus, we're going to put our A1 in again. So 90,000. Cool. Our R is 1.02. Our N, right, is equal to 10. So we want that for 10 years. And on the bottom, we're going to have 1 minus 1.02. When you put this whole thing into the calculator, you're going to see that the answer choice that you get is choice 4. Okay. Number 1 makes no type of sense. 90,000, leaving it there, it's growing at 2% for 10 years. There's no way you're only going to get $91,000. Okay. Same thing with the second one. There's no way you're only going to get a little bit more than 10,000 more, right? So it's between 3 and 4. 3 is if they said, what is the 10th term? That's why they put that there. But they don't want that. They want the total amount. Like when you add up all the numbers from the first year, the second, the third, the fourth, all the way up to the 10th. And that is going to be 985,475. Okay. All right, we're done. 44 minutes. All right, great job.